Welcome to this webinar series titled False Solutions Exposed, Busting Myths and Unveiling Real Solutions to Plastic Pollution, brought to you by the Break Free from Plastic movement. Our moderator for this session is Madhuvanti Rajkumar. Madhuvanti is a lawyer by training who completed her master's in public international law from the Leiden University in Netherlands. She currently works as a researcher in environment and climate action and solid waste management at Citizen Consumer and Civic Action Group, or CAG, based in India. CAG is a non-profit, non-political, and professional organization that works towards protecting citizens' rights in consumer and environmental issues and promoting good governance processes, including transparency, accountability, and participatory decision-making.
Before we get into the topic for today, I will give a very brief introduction about the 5-part webinar series which BFFP has been conducting. So the global Break Free from Plastic movement in Asia Pacific has launched its campaign against false solutions to plastic pollution. The campaign is titled #False Solutions Exposed, and it comes closely right after INC2 for the Global Plastics Treaty, where several key countries are yet to be swayed to play fair. And therefore, it is important to convince both local and national governments to reject false solutions, not only in the Global Plastics Treaty negotiations, but also in their own domestic policies. This campaign also follows the World Environment Day led by the UNEP on the theme of #Beat Plastic Pollution, which focuses on the solutions, the real solutions to the crisis. Now, with various kinds of solutions that are being peddled by corporations and supported by international finance institutions and governments, BFFP members have come together to hold a series of webinars that aim to debunk these false solutions to plastic pollution that are quite rampant across Asia Pacific, and as well as to promote effective and lasting solutions such as reduction in plastic production, zero waste, and reuse systems. This 5-part webinar series is held every Wednesday from June 21 to July 19. So please stay tuned to the updates from BFFP to follow, to catch each and every webinar. That being said, I think we can move on to today's session. So today we will be discussing what is waste burning or incineration, and also advanced recycling. We are pleased to have with us staunch advocates, field experts, and campaigners who are leading the fight for climate justice and against plastic pollution. We will hear from these experts and discuss questions such as what among the commonly presented solutions are considered to be false solutions, and how harmful these false solutions are, and the real solution being the need to address plastic pollution at source by capping production. So please join us in the next hour to learn and bust myths of false solutions to the plastic pollution crisis. I would like to request the audience to use our Q&A chat box for any question you may have. Please post any questions as and when you get it, and we'll get a chance to discuss it after the speakers have finished their presentations. So moving into the session, our first speaker. So the first presentation is to help us have a better understanding about waste incineration and concerns about it being presented as a solution to the plastic pollution crisis. We have with us someone who has worked for environmental health and justice for more than 20 years, and she works to address systemic failures driving the global waste and plastic pollution crisis. With a strong background in toxics disputes and environmental justice, and grounded in her own personal experience living next to the so-called West Australia's worst toxic site, our speaker works to empower communities to defend their human rights to clean air, water, and soil through the principles of the community's right to know and access to independent science and expertise. She currently leads the Zero Waste Australia campaign and works collaboratively with experts and researchers from local, state, and national and international NGOs to resist incinerators and establish zero waste city models. So please join me in welcoming Ms. Jane Bremmer, a member of IPEN, representing more than 700 public interest NGOs working for a toxics-free future at the highest level, with the International Basel, Stockholm, and Rotterdam Conventions. Welcome, Ms. Jane Bremer.
Hello, everybody. Firstly, I'd like to say that I'm coming to you today from the unceded lands of the Noongar Nation here in Western Australia. I'm speaking to you from Noongar Budja in the city of Boorloo, and that's Perth, Western Australia. I'd like to pay my respects to the traditional owners and the elders here, past, present, and emerging. Thank you so much to the Break Free from Plastic crew for inviting me to speak to you today about waste incineration. I'm going to give you a very brief summary of the main issues related to waste incineration and why it's a false solution, and it'll always be a false solution. So to start with, for us to really appreciate the damage that waste incineration and all the technologies that fall under the banner of incineration, including advanced chemical recycling, we really need to appreciate what our waste means to us. And when we look at our waste, what we can see is that we're really looking through a window into our entire materials production processes. So this reflects back to us all the design failures that drive residual waste. And it's the residual waste stream that's predominantly saturated with plastics that goes to incinerators and landfills. So we really need to appreciate what our waste represents in our world. And it's one of the most profound cross-sector pressing global issues that we face. It reflects back to us how we live on the planet and what we value. So definitions matter when we're talking about waste incineration. I'm just going to move this here. It matters, definitions matter immensely in relation to incineration, and that's because the waste management sector likes to share definitions quite loosely, and incineration is not a popular term. But under the banner of incineration, you'll find 3 or 4 main technologies, mass combustion being the main one, but also gasification and pyrolysis, which are in fact incineration technologies defined under the European Union and the US EPA. And I've put these quotes in for you to demonstrate that they are, in fact, classified as incineration technologies, and they're being sold around the world, particularly to the Global South, the Asia Pacific region, as not being incineration technologies. And we talk about waste to energy, energy from waste, anything but the term incineration, because people naturally associate it with pollution and a bad process. So we can definitely confirm that incineration technologies include mass combustion, gasification, pyrolysis, and plasma arc under the US and EU legislation. The US codes here demonstrate that. They exclude pyrolysis and gasification when it's purely a plastic feedstock and that there's an input and output ratio of at least 70%, and that the output is actually used not just as a fuel to burn, which would just be a linear combustion process, but actually used to make plastics again. And the reality is that there's really no successfully operating facilities around the world actually doing that. So, in fact, mass combustions are a fairly crude technology that takes our waste, puts it down a moving grate, and then goes through a whole series of processes. The biggest component of mass combustion incinerator is the air pollution control units. And that's because when we think about our waste, it's an entirely heterogeneous material. It's full of mixtures and composite materials and chemical combinations. And when you burn that, you create just equally chemically complex pollution. Some of the materials fall through that grate in a solid form, but most of it falls through and is regarded as bottom ash, while what's collected through the stack in the air pollution control filters is known as fly ash. Pyrolysis and gasification technologies are not new. I'm not going to go into too much detail because another speaker is going to cover this, but they're not new technologies. They've been around for a long time and were in fact created by the fossil fuel industry. They've been resurrected just recently in response to the global plastic pollution crisis. But to suggest that pyrolysis and gasification technologies are this new fandangled new technology that's going to resolve the plastic pollution crisis is not the case. They've been around for a very long time, and they were swept under the carpet by the fossil fuel industry because they didn't work 20, 30 years ago. They still don't work. And they're being rebranded in response to what is essentially a global plastic pollution crisis that the fossil fuel industry created. So we sound a bit cynical there, but I think it's quietly justified. Incineration pollution is quite serious, and it contains a load of substances, including nitrous oxides, acid gases, the full range of particulates, heavy metals, volatile organic compounds, and serious persistent organic pollutants such as dioxins and furans. More concerning, though, is that many of the pollutants that come out of incinerators come out in micro and nanoparticle sizes. And there really is no global regulatory framework to capture, monitor, and regulate nanoparticles. And we should be concerned about that because, as we saw, the range of pollutants that come out of incinerators can come out in nanoparticle sizes, lodge deep into our bodies, into our tissues and our organs, because our normal defence mechanisms can't prevent them. They're too small. Straight into the bloodstream, straight into our bodily organs. And many environmental health scientists are very concerned about this because we don't have a global regulatory framework around nanopollution. We know that incinerators not only burn this waste for small amounts of energy and a lot of toxic air pollution. This claim that incinerators are going to resolve our waste problems by preventing waste going to landfill is a nonsense. What incinerators actually do is they transform our waste into a quarter of that waste into highly toxic ash, which then requires more secure landfills. And we know that this ash is poisoning the food chain, as organisations such as IPEN, Arnica, and many other organisations have demonstrated. A lot of this ash is supposedly recycled and reused in building and construction materials, and we're assured all the time that it's securely and safely managed. Well, it's important to understand that some of the photos here demonstrate otherwise. And in Europe, where this industry has been used for a long time, the incinerator ash problem is significant and impacting the environment. It's not being safely regulated. Does waste incineration prevent the spread of contamination that would come through landfilling or our waste in general? Well, some studies more recently show that incinerators emit in their ash and their emissions to air PFAS chemicals, as well as microplastics. So this suggestion that burning plastic waste is a safer way to manage our waste, it keeps it out of landfill, it keeps it out of the environment, is not supported by evidence. And that evidence is showing that it's being released to the atmosphere in micro and nanoparticles. We should take a close look at what's happening in Europe, because as many in the Asia Pacific region and the Global South know, incineration is being sold to us as a high-tech green solution for our waste management that's regulated heavily in the EU. And as long as these incinerators operate to EU strict standards, they won't pollute or harm the environment. Well, that's not the case either, and studies around some of the the best operating incinerators, some that are even exceeding the EU's so-called strict standards, are showing that the residues of pollution left in the environment around these best operating facilities are leaving dangerous, persistent organic pollutants. And so the reality on the ground around these incinerators isn't matching the regulation that the government's referring to, or the standards that the industry is saying that they're adhering to. And some of this is around how the pollution is measured. For example, incinerators, when they're operating to standards, might not release so much pollution, but there are a whole range of scenarios when an incinerator operates that generates pollution, and they're known as other than normal operating conditions. So when the incinerator starts up, when it shuts down, when there's a bypass of it, when they clean the filters, the pollution that's released during those events can be in one release a year's worth of pollution. So the EU standards only require a once every 6 months test for dioxin, which is ridiculous. So scientists in the Netherlands took a closer look, and they realised that the requirements that Europe put on incinerators to measure these persistent organic pollutants was insufficient, and that when they applied a continuous emissions monitoring system, they picked up significantly higher levels of persistent organic pollutants that demonstrated why these contaminants were being found in the surrounding environment, in the eggs, in the dairy, in the grass, in the meat, in those agricultural areas around incinerators where we were told there was not going to be any pollution, but yet the evidence on the ground shows otherwise. And this is one of the reasons. Why should we be concerned about incineration pollution, particularly for children? Because children are not little adults. They don't process contaminants, pollutants the way that adults do. We don't have a regulatory system that adequately accounts for the vulnerability, particularly of children. Children simply inhale, ingest, and absorb more pollution than adults, and they don't have the toxic elimination system to be able to deal with that pollution. And it affects lifelong fundamental windows of development for children. So if we set our standards to protect children's health instead of the convenience of incinerator companies, then we're not only protecting children's environmental health, we're protecting the planet. And there are numerous studies all over the world that have demonstrated the harmful impacts of incinerator pollution on human health. Here are some of them. Why we should look to Europe? Well, Europe has recognised all this and has set policy to encourage member states in Europe to decommission incinerators, to not build new ones, and to move to zero waste systems. And they do this because they recognise that incineration inevitably undermines recycling and a circular economy. So even the countries that are where these incinerators are coming from, their countries of origin are saying, this is an industry that's in decline and needs to shut down because it's a major and direct threat to the circular economy and the recycling industry. And that's why they've removed their renewable energy subsidies for this sector in their latest taxonomy report, where they classify incineration in the same category as coal and nuclear power. In short, incineration is the most expensive way to make energy, and it's the most polluting way to make energy. Per unit of energy, it's more polluting than coal, oil and gas. We know that the strong narrative that's coming out now about taking our waste and finding these great new technologies such as pyrolysis and gasification, which I mentioned earlier, are not new at all, are false solutions, and they just lead to more toxic outcomes in terms of toxic ash, toxic fuel, turning plastic and our waste into fuel to burn in a whole range of industrial processes like cement kilns, pulp mills, any combustion industry, fuel all over the global south. Really is a recipe for disaster and increased pollution and human health harms. And there's a range of documents there that I showed that are demonstrating. Finally, incineration, as we know, if anyone's familiar with the Ellen MacArthur Foundation, a leading organisation promoting the circular economy, they clearly exclude incineration from the circular economy. In fact, it's a leakage. And so that's because it's a linear process. Burning our waste, burning our plastic is a linear process where that carbon is released directly to the atmosphere at a time in our global history when we really need to be putting that carbon back into our biosphere, sequestering that carbon into our biosphere and not transferring it to our atmosphere. So I hope I haven't gone over too much there. I know it was a very fast, short comment on the main points of incineration, but I hope that helps. So thank you very much.
Thanks for a very precise and a crisp presentation. I actually had a question on the children's health point, but I think I will reserve it later for the Q&A session. And the audience, in the meantime, if you have any questions or points of discussion after Jane's presentation, please put it in the chat box so that after all three speakers finish, we can discuss it. Jane, I, however, had one clarification, if I may. So at the beginning of your presentation, you mentioned something about a design failure. So when you say design failure, it's obviously at the upstream or the midstream stage. But my question is, do you believe that the design failure is intentional, or is it because of lack of alternatives or technologies to properly manage it?
Well, at risk of sounding cynical, I'd have to say that some of it must be intentional. I mean, the design of single-use plastics and single-use anything, that entire concept is a design failure because we're not valuing the resource. It's just wasted. So single-use anything, in my mind, is a design failure, but I think that there are some pretty hefty design failures in plastic production and plastic materials, full stop. Plastics are not just simple oil, solidified. They're full of additives and chemicals. And that's what's really impeding the ability to recycle safely. The fact that they don't decompose, the fact that, you know, I don't want to sound cynical, but it's impossible to, because we're breathing in microplastics. We're drinking microplastics. Our entire planet is polluted with microplastics. That in and of itself suggests that plastics by design has been a massive global design failure, and we need urgent action.
All right. Thank you. Thanks so much, Jane. So let's move on to our next presentation. In the next presentation, we are going to get a deeper understanding of the different kinds of recycling, like mechanical or chemical or advanced recycling, whatever they call it. The expert we have for this topic is our next speaker, who is a research faculty fellow and adjunct professor of environmental science and of engineering at Silliman University in the Philippines. Among his current research interests are zero waste, plastics pollution, microplastics, and chemicals used in plastics. So we have with us here Dr. Jorge Emanuel, who has been involved in War on Waste and Break Free from Plastic and the Zero Waste Cities project in Negros Oriental. War on Waste, WOW BFFP Negros Oriental, is a collective of NGOs, academics, and individuals in the Philippines, brought together by their passion to help solve the waste crisis through zero waste models. From 2003 to 2015, he was the chief technical advisor for global environmental projects of the UNDP. And prior to that, in the 1970s and 80s, he was a polymer scientist working for the then world's largest producer of engineered thermoplastics. He is trained in chemical engineering, chemistry, environmental management, and public health. So we can expect a wealth of information from him today. So please join me in welcoming Dr. Jorge Emanuel.
Thanks, Madhu. And what I'd like to do, let me begin by looking at the larger picture. This is a diagram that shows where all the plastics ever produced between 1950 to 2015 have gone. The estimate of total virgin plastic produced was 8.3 billion tons, shown on the right. Of this amount, 5.8 billion tons have been used once and have become waste, leaving 2.5 billion still in use. Out of the 5.8 billion tons of waste, 4.6 billion have been discarded and are now somewhere in the environment, in our landfills, dump sites, our farms, our rivers, our oceans. Another portion has been incinerated, creating toxic ash and air pollutants, and only 0.5 billion tons were recycled, and then eventually, again, discarded in the environment or incinerated, and only 0.1 billion tons remain in use. We will come back to this at the end. The common definition of mechanical recycling is the processing of plastic waste into secondary raw material without changing the chemical structure of the material. Mechanical or conventional recycling involves collection, sorting, washing, shredding, and grinding. These processes can be in different order, but the end result is recycled plastic pellets or flakes, which are then used as secondary raw material to make new plastic products. Here are examples of mechanical recycling. The top shows manual recycling involving manual sorting, washing, and grinding to make flakes, as shown in the left photo. Manual recycling creates many jobs. The bottom shows an automated recycling system, which uses automated sensors, such as a near-infrared sensor to distinguish between different types of plastics on a conveyor belt, along with other automated sorting systems, like visible spectra to separate by color. The system is followed by a shredder and washer, a drying process, and an extruder pelletizer to then make the pellets, shown on the lower right photo. This slide shows one limitation of mechanical recycling. The 6 plastics at the top are the commodity plastics, the plastics produced at high volume and low cost. The plastics are represented by the abbreviation of the synthetic polymer that comprise each of them. These plastics correspond to the resin identification codes 1 to 6. Of all the types of plastics, only 3 plastics, number 1, number 2, and number 5, are commonly recycled. The rest of the plastics here, shown here, and this is not a complete list, are generally not recycled or are impossible to recycle. This slide summarizes the benefits and limitations of mechanical recycling. Mechanical recycling reduces fossil fuel and energy use by reducing the amount of virgin plastic needed. It reduces greenhouse gases by about 30% compared to virgin plastic. Recycling means less plastic going to the environment in the immediate term. It creates jobs and is cost-effective compared to virgin plastic manufacturing for the commonly recycled plastics, but only if the plastic waste is well sorted, transport costs are low, and the level of contamination is minimal. Although recycling reduces the amount of fossil fuel in virgin plastics, recycling does not eliminate them. This is because plastics degrade each time they are remelted, so the addition of new virgin plastic is needed to achieve the same quality, unlike glass or aluminum, which are infinitely recyclable without loss of quality. This is the first point on my limitations. Because recycling does not eliminate the need for virgin plastic, recycling, in my view, is an interim solution. Also, only a small fraction of plastics are even recycled due to dangers. Many plastics release toxic substances when melted, or technological difficulty. For example, plastic films damage recycling equipment, or being technically impossible. For example, all the thermosets decompose when melted. Also, because plastic waste is inconsistent in quality and often contaminated, recycled plastics are usually downcycled to produce a product of lower value. 2 issues are of increasing concern. Studies show that recycling facilities are a source of microplastics and of wastewater pollution. Also, plastics contain some 10,000 chemical additives. Most additives have not been tested for hazardous properties. Moreover, plastic wastes have additional contaminants from residues or those picked up from the environment. Importantly, recycling, if not coupled with campaigns to reduce plastic consumption, recycling can be a perverse incentive to keep generating plastic waste. Chemical recycling can be defined as a group of processes that use heat, pressure, or chemical reactions to break down the chemical structure of the plastics into monomers or intermediates, the building blocks for making new polymers that comprise the plastics. Terms such as depolymerization, catalytic cracking, etc. have been used. I want to distinguish another form of advanced recycling called dissolution recycling. Although it does not change the chemical structure, it uses chemical solvents to selectively separate one or more plastics from a mixture. Now, chemical processes that form plastics that are burnt or that create chemicals as feedstock for the chemical industry for non-plastic materials are not recycling. This graphic illustrates the basic differences. We start with fossil fuel extraction, refining of crude oil, and the manufacturing of petrochemicals on the top left. From the petrochemicals come monomers, or the building blocks of polymers. These monomers are then reacted to produce the polymers, which comprise the plastics. The plastics are then formed into pellets or flakes, which are then used as the primary raw materials, along with many chemical additives, to make the plastic products. After consumer use, the plastic can be reused, or it can be sorted, washed, and shredded to form pellets or flakes, which along with virgin plastic are made into new product. This is mechanical recycling. If the plastic waste is treated with a chemical solvent to selectively remove a specific polymer, this is dissolution recycling. If the plastic is processed at high temperature, pressure, or reacted with chemical reagents to break it down to its monomer or intermediate, this is chemical recycling. The same or similar processes produce other chemical byproducts, so they have been proposed for making feedstock for the petrochemical industry or for burning, as shown by the dashed line, but these are not recycling. Here are specific examples. The three most common chemical recycling processes used for PET plastic are shown on the left. The terms glycolysis, methanolysis, hydrolysis refer to chemical reactions. They involve high temperatures, high pressures, and the use of hazardous reagents. The diagram on the right showed two dissolution recycling processes for separating polyamide and low-density polyethylene. What are the challenges and limitations of chemical recycling? First, most of the technologies are very energy intensive and result in high greenhouse gas emissions. Secondly, they use hazardous chemicals and produce toxic byproducts which could impact public health. These technologies work in a laboratory or pilot scale under controlled conditions. In the real world, however, plastic waste is mixed, the feedstock is not clean, and many chemicals contaminate the plastics. For these reasons, it is difficult to deploy chemical recycling at a global scale. These processes get a lot of media hype, even though many technological hurdles remain. In the few chemical recycling facilities, studies have even found that as much as 35% of the input plastic is lost. The high energy and chemical inputs and the cost of separating and purifying the products make chemical recycling uneconomical because they tend to be highly automated. They generate very few jobs compared to mechanical recycling. Importantly, it is unlikely that these technologies can operate economically in the real world at global scale. Therefore, they will not make much of a dent on the global plastic crisis, but they are heavily promoted today by the plastic and petrochemical industry as solutions. This would not be the first time that the industry has hyped so-called solutions, which distract society from enacting real solutions that address the problem at the source. I view this hyping as greenwashing. I'll end as I began with a larger context. As the diagram shows, plastic recycling only delays but does not avoid the problem of plastic waste disposal. In the end, all of the plastic will end up in the environment in some form or another. And in coming decades and centuries, they will cycle in our planet as more and more microplastics contaminated with toxic substances circulating in our oceans, our soils, our food, and our bodies before they fully degrade after many generations. The only long-term solution is to reduce the production of plastics in the coming years and to adopt real solutions such as zero waste. Thanks.
Thank you. Thank you, Dr. Jorge. It was an excellent presentation explaining the science behind chemical and mechanical recycling. Before we move on to our next speaker, I just have one quick clarification, Dr. Jorge, if I may. So you mentioned that you mentioned about purification process in the recycling process, and you also mentioned that there are about 10,000 chemicals involved in the process, and out of which how many of them are toxic, and is it possible to remove the toxicity during the purification process in mechanical recycling?
In mechanical recycling. First of all, the answer to your first question is we don't know how many are hazardous, but just by looking at the structures, we suspect most of these are hazardous. This is one of the problems because many of these chemicals have been allowed and only a few have really been tested for their hazardous properties. And this is especially true even with food grade plastic. This is an important last point because people assume that all these chemicals, of which there are 8,000 added in food grade plastic in the European Union, about 10,000 added in the US for food grade plastic. And yet very few of these have actually ever been tested, especially for many of the things that concern us, such as endocrine disruption and even for things like cancer and so on. So this is a big concern. Now, your second point is, can these be removed? The short answer is they cannot, because many of these are in the plastic itself, and so they migrate out of the plastic with time. And so in typical mechanical recycling, we are dealing with plastics that can only be washed, and so you can only remove the plastics, the chemicals that are soluble in water. Many of these toxic chemicals are not soluble in water, and they're soluble in organic solvents. So even the purification process requires some very toxic chemicals and a lot of money, and this is why it is not practical. Dissolution recycling is really not practical because of the amount of money it entails.
Yeah, thank you. Thank you so much for the clarification. So we have one more speaker left. So thus far, we've talked about problems. We've talked about incineration, why waste burning is bad, why chemical recycling and advanced recycling are bad. So now it's time to talk about the real solutions to the plastic pollution. And to discuss, of course, we are all aware at this point that the real solution to the crisis is to cap production at the upstream stage. But however, to discuss zero waste approaches, we have with us the Executive Director of Gaia Asia Pacific, the Global Alliance for Incinerator Alternatives. Gaia is a global network that aims to catalyze a global shift towards environmental justice by strengthening grassroots social movements that advance solutions to waste and to pollution. The network envisions a just zero waste world built on respect for ecological limits and community rights, where people are free from the burden of toxic pollution and resources are sustainably conserved and not burned or dumped. So let's hear from our expert, Mr. Freulen-Gate.
So we know the problem. The two speakers have covered some of the false solutions that we've been seeing, but for many of us, especially for those of us in the Asia Pacific region, we know the problem because for most of us, we live and we have this as our everyday experience. And we've also been bombarded by false narratives, no? And these false narratives leads to false solutions, two of which has been covered by Jane and Jorge a while ago. But we know that there is a better solution, and that is zero waste. So let's just briefly explore what zero waste is and how is it being done in our parts of the world. No? So in basic simple terms, zero waste, as we translate it in our language, is that nothing is wasted. It doesn't mean that you don't throw things for after you're using them. It just means that a the things that we use has value, has function even after the purpose that we initially thought of it. No, so the organics is being returned into the system via composting. The recyclables, especially the paper, the metals, are being recycled, and the problematic ones, those that are not able to be recycled or composted, we don't try to bury them or hide them in landfills. No, we try to identify them so that we can come up with better solutions like redesign, banning certain materials because there's no value for the community, or extended producer responsibility, or exploring alternative delivery systems for some of this. And we know that zero waste is much better compared to the linear waste management that many of us are familiar with. One, it's decentralized, so it empowers communities. It creates jobs as a result. Again, we don't hide or bury the waste, we identify them. And after identifying them, we come up with solutions to reduce those specific types of waste. And compared to waste management, where it's capital intensive, linear waste management is capital intensive, no, it has no incentive for waste reduction. And in zero waste, we're seeing magic, like even if we increase the scope of waste collection, it doesn't have to translate into more waste that has to be disposed of in our disposal facilities, like these examples in one city in the Philippines where they were able to increase their coverage from 30% to 100%. But instead of the waste increasing, it actually decreased, no, from 90 tons to 66 tons that has been sent to the landfill every day. And this despite, again, increasing waste collection coverage from 30% to 100%. So this is waste. No, this is garbage. But in a zero waste system, we don't look at it and we don't see it this way because we are actually preventing waste from reaching that point. In the last picture we've seen a while ago, where if we're able to segregate the materials, then most of them can be considered resources, especially in Asia, where more than 60% of our waste are organics. They can be compost, no, and then a certain segment for recycling, and then we're left with a small portion that is problematic. And then this is where, again, we could explore options like banning certain materials, redesigning them, or exploring alternative delivery systems. Zero waste also allows us to change the narrative. No, from that table I've shared a while ago, where countries are being blamed for the problem of plastic pollution, and two, really identifying who are accountable, who are responsible for many of these problems, no, via one tool that we're using, like the waste and brand audits. And zero waste allows us to transform communities from places where plastic pollution is visible and to places where solutions are happening. So like this one community in the Philippines, where in less than 6 months, they were able to transform their transfer station into a materials recovery facility, that something that the community is now proud, no, and something that they're not actually avoiding when they're passing. They even go here to have a party or have a picnic. So that is just a brief overview of what zero waste is. Now, the beauty about zero waste is that it's not just a concept, it's not just a vision. It's both a vision and something that we know is already happening in many parts of Asia and the world. No? So very briefly, let's just go through some of these examples. There are several stories from Penang, Malaysia, and many others, but you'll have access to these case studies if you're interested to learn more. But just very briefly, just look at some of these examples, like this community in Malabon in the Philippines that achieved 80% waste diversion in 12 months. And in just one community, they were able to employ more than 60 waste workers who were previously informal waste speakers in the community. We have examples from Pune in India, where we see what could be the result of putting waste speakers front and center in terms of addressing waste, empowering them and recognizing their contributions. We also see how involving the youth or focusing on organics has made significant improvement in waste management in Trivandrum in India. We're seeing how in Bandung in Indonesia, just by starting with several pilots, they were able to show that compliance is actually possible in their context. And this resulted in more investment for waste management within the city, and then is translated into provincial and regional policies on waste management. You might have seen viral stories about Kamikatsu in Japan, that is promoting the 4Ls: local, low cost, low impact, and low tech. We have the stories from Seoul, South Korea, to see not just in Southeast Asian context, but in Asian context in highly urbanized cities, zero waste could be implemented. So these are just some of the examples to show where zero waste is proving that it's not just a concept, it's already happening. But what I want to highlight, if you're interested to learn more how zero waste is implemented, there's a Zero Waste Academy that you could join to learn more about this. But as we transition towards the current system that we have, where communities are impacted, workers are impacted, we have to ensure that those sectors that are currently carrying the brunt of the impact of our current systems are considered in terms of how we transition into a zero waste system. And I think that's best because in a zero waste system, people and communities are front and center, not the interest of corporations, not the interest of the stakeholders, the investors and their profits. But it is what's good for the planet and what's good for the people. So just to emphasize this, that we all need to be working on a just transition for all impacted communities. And we don't have the time to go through this, but just to highlight that if the process of transition is not just, the outcome will never be. So that's something worth reminding for all of us. And currently, BFFP is undergoing a development of a just transition framework. So we invite everyone to participate in that process once that's being rolled out sometime in August and September. The good thing is that we have examples of how when we put forward the interest and the context of the impacted communities, results could be seen, like how we are seeing in Swatch in Pune, where they have empowered, they have organized the waste pickers. And it all boils down to one, recognizing that these impacted communities exist, they have leadership, they have a voice, and we need to create spaces in our communities for their voices, because ultimately, we share the same vision of a future free from plastic pollution, but the timeline might be different for some, and this is where support for just transition is needed. So I think that's all the time I have for this afternoon, and be happy to answer questions or clarifications and provide links to some of the case studies if you're interested. Thank you. Back to you, Madhu.
Thank you, Froy. Thank you for sticking right on time. So that's all the presentations we have today. Before I see some questions in the chat box. Before we go to that, I just wanted to reinforce or reiterate one point which Froy said, that zero waste is not just a model of rules or protocol. It's more of a lifestyle. And nowadays, when we say garbage, trash, or waste, we mean it like we use a negative connotation to it, to think of it as something useless. But under the zero waste model, even waste can be a wealth for us. So that is another a really nice point which I liked in Froy's presentation. So let's move on to the questions. Okay, we have a couple of them. Aya, how much do we have time for?
Let's accommodate what we can given the time.
Okay.
Yeah, in order. Thank you.
All right. So the first question is there any plastic which is biodegradable? Freud, would you like to take that?
I think Jorge is the best person to answer that.
All right. Jorge, please.
Oh, yeah, sorry. Yeah, let me give my thoughts. I make a distinction between polymers and plastics. So I've worked in both fields, obviously, but in polymers, polymers are just basically huge molecules with repeating units. And there are many of those in nature, and they do degrade. But plastics are primarily synthetic polymers, in some cases semi-synthetic. They add a little bit of um, of biopolymers, for example. And so there are polymers that do degrade, and there are some that are biodegradable. But here are some of the issues that we have to watch out for. In the Philippines, for example, you can go around and see bags that say biodegradable plastic, when in reality they are not, because the first step often for a plastic to degrade is they have to fragment into small pieces. Ironically enough, that's a big danger to us because it creates precisely microplastics. And so for plastics to be able to fragment easily, we often would put a heavy metal in between the chains, which means that the degradable plastic are often with heavy metals. But that shouldn't be end of the picture, because even though they break into small pieces and they disappear from your eyes after a matter of months, for example, and this is what makes people think that the problem is solved, in fact, the pieces of polymers that are there are going to be there still for decades and hundreds of years. And so for a plastic to be truly degradable, all of that, you have to show that all of that can break down into carbon dioxide and water and biomass. And many of the ones that have been tested turn out not to be able to do that. Now, there are a few that are made that can actually meet the requirements of both, but they often fail on yet the third test, and that is, what are the toxic effects of the broken down so-called biodegradable plastics. And so different tests are available, usually ecotoxicological tests, but basically what happens is, because of all the chemicals that have been made to be able to create it, there is still a problem of toxicity left. And so and the last portion is whether they are compostable, and that becomes yet another issue, because often, even if they pass the first three tests, they are compostable only under very specific requirements, and so they are still not practical for our everyday use. So those are the concerns I have on the so-called biodegradable plastics. I think many, especially in developing countries, are simply mislabeled. They are basically the oxo-degradable plastics that break down into microplastics and make the situation even worse.
Thank you. Thank you, Dr. Jorge. I think I'll take the next question for Jane. A question from Swen is that, are there any studies that show that microplastics or nanoplastics in our food and our bodies and are a threat to human life? And does plastic pollution pose an existential threat to humans or other species?
Well, the short answer to that is yes. There are studies, I can't quote them off the top of my head, but there are a range of studies that show that micro and nanoparticles that we ingest harm human health. It reminds me of a webinar that I attended several years ago international environmental health experts came together at the very beginning of this awakening of plastic pollution. And the presentations that were presented there changed my life. The evidence of plastic fibres coming through the wastewater system, coming from land, flowing into the oceans from textiles was incredible, and as such small particles. And these international environmental health experts suggested that plastic pollution of our planet and its impact on human health was the greatest human health threat of the Anthropocene. And they came to this view because of the very nature of plastic is that it doesn't break down. And so when we have microplastics, nanoplastic particles, fibres in the environment, for example, when they float around in the ocean, they adsorb toxic substances. So they become super toxic particles. When these particles enter the body, they remain. And so they remain with all those toxic chemicals attached, which we know those chemicals cause human health impacts. That's well documented. The particles themselves sit there and don't do anything, don't go anywhere. And it's the inflammation potential that these particles in the body cause that some scientists have said that they believe is the cause of all chronic disease, human health, chronic disease, and ill health. So there certainly are. Go to our websites. I mean, a lot of people are asking for resources. I can see in the chat section. Please go to the websites of Zero Waste Australia, Gaia, Break Free from Plastic, IPEN. You will find all the reports and all the fact sheets you need and all the references demonstrating the harms to human health that plastic causes. We know that there are many studies demonstrating the impacts on the lives of seabirds, especially in marine species. It's a growing body of evidence, but it's very clear that micro and nano plastics impact human health quite dramatically. And that's why we're working towards a global treaty, exactly for those reasons, because we have a global catastrophe. Our planet is saturated with microfibers, microplastics. We know that they cause harm, and yet industry is just on a path to expansion, and we don't have the systems to capture that yet. So it's a looming disaster. In fact, many of us consider it the greatest threat to humanity and the planet of all times right at this moment. So sorry to be a bringer of not very good news, but there's plenty of resources out there. Please visit our websites. It's all there.
Thank you, Jane, for the answer. So since we seem to be running short of time, I will just pick up one more question. But in the meantime, panelists, please feel free to type your answers right in the chat box. And if your question is unanswered, we will collect all of them and we will email the answers to you. So please do not worry. So the last question for today's session is to Roy from Mr. Rohit Roy. Mr. Rohit is confused by the contradiction of a zero waste strategy that relies on a plastic recycling industry for the livelihoods of the workers, while at the same time, these recycling methods are often polluting, as discussed by Dr. Jorge. So how do you resolve this contradiction? Over to you, Roy.
Thank you, Madhu, and thank you, Rohit, for the question. From our perspective, there's no contradiction. One clarification is that a zero waste system does not depend on plastic recycling. If we refer back to the hierarchy of our 3 R's, zero waste focuses first on reduction, recognizing that currently the recycling system is broken, but with regards to waste pickers, that should not be something that stops us from pursuing real zero waste. In zero waste systems in Southeast Asia, for example, waste workers and waste pickers are paid for the service that they provide, not for the materials. So even if we eliminate some of these problematic materials, even if we shift from single use to alternative delivery system, one that fully focuses on reduction and reuse, for example, our position is that these should not disenfranchise waste pickers and waste workers because they should be compensated for the full service that they provide us. irregardless of what material is being used in the system. So no, there should be no contradiction. We should pursue full reduction and stop production of plastic but recognizing that as we transition to this system, these waste workers should be supported. And one way to support them is to ensure that we call for fair wages for them to pay for the service that they provide. Again, not for the materials that they collect. So hopefully that answers the question.
So we've come to the end of the session. Thank you to everybody who joined us today. So to quickly summarize, today we heard about the health impacts of waste burning and why waste burning or incineration as a solution that is propagated by governments and corporations why is it a false solution, why it doesn't work. And although there are so many governments which have approved or promote the incinerations themselves, they say that if you are within these permissible limits of emissions, then it's fine. But then the problem is those permissible limits have been set a really long time ago, and they're not up to date with our current temperature of the earth or our current emission standards. So, so incineration why is it a false solution is something that we learned today. And I really liked the point which Dr. Emmanuel made that recycling is not a one-stop solution, that it only delays, it doesn't prevent or it doesn't help solve the problem. So I think recycling is one common word which everybody has heard, it doesn't matter global south or north, but especially in the north, people are under the impression that, okay, once you use something and you throw it away, it goes into recycling and it becomes something new and it's put into use again. But that's not the case. There are so many energy intensive processes that goes in between. And the percentage of recycling that we do is extremely, extremely negligible. And so these are the two main problems that we discussed. And we had Froy's presentation on why we need to go zero waste, not as a solution, not as a fix, but as a lifestyle for the preservation of humankind and also for the conservation of resources and for the survival of the planet, why we need to adopt this lifestyle of zero waste. So it's been an extremely exciting session. I learned a lot personally, and I hope you also learned a lot. I would like to take this opportunity to thank BFFP for organizing this session. And thank you to our speakers, Jane Bremer, Dr. Jorge Emmanuel, and Fräulein Great. Thank you for your time and for agreeing to join us today to share your insights around waste incineration, advanced recycling, and zero waste approaches. I would also like to mention that BFFP recently launched a resource that you may use on identifying what is greenwashing and communicating about false claims and false solutions. So, will you put it in the chat about the resources?
Yes, we'll send the link.
Okay, so please join us in our next 3 sessions in this series of hashtag false solutions exposed, busting myths and unveiling real solutions to plastic pollution. In our next session, we will talk about a very important subject of plastic credits and reuse systems. This session is happening on June 5th, same day, Wednesday. Every Wednesday, we have a webinar. And the time is also the same, 1:30 p.m. for Delhi, 4 p.m. for Manila, and 8 p.m. for Auckland. And to learn more about the campaign and the resources or the learning opportunities available to you, please check out the Break Free from Plastic website. And so with that, on behalf of the Global Break Free from Plastic movement, thank you for joining us here at hashtag False Solutions Exposed webinar series. Thank you so much.
What do Exxon, Greenpeace, and Rwanda have in common? The answer might surprise you. A lot of people don't know this, but right now, 175 countries are negotiating a treaty to solve plastic pollution. And there are a lot of players in the room. Let's break it down. We all know about the plastic problem at this point. It's a problem so big that no country alone can solve it. So last year, global talks began to forge an international plastics treaty. It's a big deal. But an even bigger deal is that countries agreed it'll be legally binding. That means if governments don't abide by it, there could be actual consequences. And now, world leaders are meeting periodically to negotiate the terms of the agreement. But the devil's in the details, and this is where you're going to come in, so pay attention. We need a plastics treaty that, one, has deadlines to slash plastic production. Ending the cycle of plastic pollution for good requires getting to the root of the problem by cutting plastic production. See, the plastics crisis is fundamentally a crisis of volume. There's so much plastic being created right now that it's just totally unmanageable. Basically, if you've got an overflowing bathtub, don't bail it out with a teaspoon, turn off the faucet. 2, we need a plastics treaty that advances environmental justice. We need this treaty to prioritize the health, livelihoods, and expertise of communities and workers all along the plastic supply chain. Look, we know plastic harms people. The fossil fuels and chemicals it's made of are toxic, and they pollute our air, our water, our food, and even our bodies. So those most impacted, whether they live next to an ethane cracker in Pennsylvania or work as a waste picker in the Philippines, need to be at the decision-making table. Number 3, we need a treaty that rejects false solutions. Major polluters like Exxon are lobbying for a weaker treaty. But why are the companies that created the problem even allowed in the room in the first place? And the things the industry is pushing, like what they call advanced recycling or plastic offsets or more beach cleanups, those are not real solutions. They're just greenwashing tactics that let industry keep making more plastic. With negotiations underway, we need to build enough public pressure around the world to make sure the treaty is strong enough to solve the problem. And we need to keep certain companies and countries from getting in the way. The good news is, many countries are advocating for strong terms. Let's call them the High Ambition Coalition. Nations like Rwanda and Ecuador and Norway and Peru, they're leading the way. Other countries, not so much. Some of the world's most powerful countries, like the US, where I live, and Saudi Arabia, they're resistant to passing a strong treaty because they're the major producers of either plastic or the fossil fuels that plastics are made of. So this is where you come in. If you've felt helpless, or like, my individual actions can only do so much, this is the opportunity for the major sweeping changes that we've been waiting for. But world leaders need to hear from us. We need participation from people like you and me to make sure we're drowning out corporate lobbying and getting the strongest possible plastics treaty we can. So what kind of treaty will the citizens of the Earth get? The one we fight for.